Wow, hello. This is awesome to be here. No, Chippy has a worldwide reputation, I was telling Brian. One of the oldest and most venerated and strongest Python users group. I think we were talking about my dear friend, John Hunter, who helped establish this group years ago. And every time I come back to Chicago, I think about him. He was a great man who helped start Matplotlib. He helped me start NumFocus. I had a lot of interactions with him. I really enjoyed him. But look at the legacy that everybody who's been working so hard in Python community for 20 years has produced. It's actually amazing to see. Imagine this crowd now kind of in 500 cities around the world. I was just in Estonia this past March. I've been in Paris. I've been in London. I've been in India. I've been in Thailand. And you have in Barcelona just a year ago. You have the same kind of energy in each one of these places. And it's not, what's amazing about the Python community is it's a community energy. There are companies dancing around, but the core of Python is actually a group of volunteers, a group of people who want to make it work. And that's been the way it has been for 20 years. It's actually really amazing and unique, I think, among some of the open source activities out there. So I only have a little bit of time here, so I think, what can I share with this great group of people? And I'm happy to talk to anybody at drinks or afterwards about more of the things I'm doing. What I thought I'd do is just give you a brief update, like 5 minutes, about what I'm doing now, and a little bit of what I've done in the past. But I'm going to just kind of dive in on some things some things about NumPy you might not know, and some things about new ideas that we're working on for the future. So that's what I think we'll try to do. And if we have a lot of people here, so it's maybe hard to ask questions. If you're brave enough to speak up and ask a question, I may be able to do it that way. Okay, let's see if I can make something work. Is it working? Okay, so me, I used to be a scientist. I was at the Mayo Clinic. I came to Chicago many, many years ago for an ultrasound convention here. First time I visited Chicago, it was awesome. I thought I would do science my whole career, and instead I've kind of been writing tools for scientists, and then now data scientists, and now machine learning practitioners and others. SciPy was my baby. SciPy was what I started as a grad student when I was very young. It's grown, fortunately, in this big organization. It was far too big. My dreams were far too much bigger than my ability to individually do something. But I used to be a professor. As a professor, I wrote NumPy instead of write papers, and so now I had to go to business instead of have tenure. That's something that's played out for several people. Actually, Fernando Perez trudged along, and I just had a phone call with him the other day, and he has tenure at Berkeley now, actually. I think almost really close, or he's got a really nice position there now. So it's actually really cool, and we talked about kind of the journey that it took for him to get to that position. Open source is an amazing phenomenon. It's something that definitely academics should be supporting and kind of integrating with. But like all human institutions, things take a long time to change. Human institutions I'm slow, right? It takes me a long time to figure out something new. So, and groups of people working together, it takes a while to adjust them, but we do it, and we keep moving forward. Most people know me because of NumPy, but NumPy I wrote out of duty because I saw what was happening in the SciPy community, and I wanted to join things together. Although today, after 2016, 2017, with all the TensorFlow and Torch and MXNet and numerous array libraries that actually, if any of you here are not confused about what's going on in the ecosystem, come talk to me because I'd like to pick your brain. Because I'm actually kind of confused. So there's a lot going on, and in fact, it makes kind of that story I used to tell about, I made NumPy to bring NumArray and numeric together, kind of quaint. It's like, I was in the back 40 farming, and Big Ag moved in. And that's kind of true. It's really, really grown quite a bit. Early on, 6 years ago, when I started Continuum, which became known Anaconda, I've been in business because I love open source, but I want to be able to pay people to work on open source. And so I'm just trying to keep figuring out how to do that. And a lot of people are doing that as well, and it's really cool, but I like to do that too. So that's what drives me, is how do I construct organizations and groups and concepts to fund the things that I think are interesting. NumFocus came out of that. My recent company that I started just in January is called Quansight, because PyData keeps growing and Python keeps growing. Quansight's purpose is to basically go and, when we started Continuum, we had kind of what I realize now was an engine for creating companies. And we created one called Anaconda that came out of Continuum, and it grew so rapidly it kind of consumed the parent. And Anaconda is now growing forward, but we had a lot of other ideas we were pursuing at Continuum that now we continue it Quansight, which will just give rise to new companies. New ideas come along, we come up with another big idea, we'll spin it out as a new company, and Quansight will stay around. So we grow talent, we build technology, discover products. We have a mentor to hire model, we have a teaching hospital notion, we take people who are early in their careers, pair them with other people, work on projects together, and then hopefully get them good jobs, place them in the industry. We do open source development. We have a model called a sustainable open source subscription. Basically, to communities, we help them organize their roadmaps into fundable nuggets. To companies, we take those fundable nuggets, help them recognize if they instead of reinventing the wheel, they can prioritize open source and save millions of dollars internally. So we basically connect companies with communities. Companies, we help them prioritize their OSS roadmap, help them hire from the community, and then we also help them, excuse me, we also help them mitigate their community health risk, help them understand their OSS dependency. That's what I'm doing now at Quansight. If you have any questions about that, love to help you. If you're an open source developer who has a community you'd like us to help you promote, I can also help you do that. We're involved in that aspect of things. But I'll spend the rest of the time, my few minutes I have left, talking about cool things. Those are cool things too, but this is maybe, I really have had a lot of fun recently. So at Anaconda, we watched it grow, and I was spending so much time just doing business stuff that I love just doing technology development too, or at least technology exploration. You probably can't see any of this. So I've been exploring here, and I thought I'd talk just about NumPy a little bit. And I'm using Jupyter Lab. Any Jupyter Lab users in the audience? Okay. I'll come back in a year, you'll all be raising your hands, right? Jupyter Lab is really super cool. And if you're not, just like I saw the survey, the Stack Overflow survey. In fact, I have it here. I'm doing a notebook to look at the Stack Overflow survey. And this is they don't even have Jupyter Lab here separated, right? But this is, whenever you ask someone what editors they use, you're always going to get something like this. Like, editors are like personal. You're not going to, I'm going to use the editor I want because that's how I learned to do it. I understand that, and that's great. But all of you will have Jupyter Lab, at least one of the 20 editors you decide to use in your life. And the reason is because it's kind of a cool platform for building applications around. NumPy, how many NumPy users in the audience? All right, so, and the rest of you don't realize you are a NumPy user, right? Perfect, great. Well, and that's fine. Actually, the more NumPy's gone along, it's kind of become hidden underneath the seams because people are fortunately turning to higher level libraries that are a little more friendly. But it's also causing a little bit of stress. When I wrote NumPy, I didn't think of NumPy as a library. I kind of thought of it as this is before IPython, before there's just a REPL, and NumPy was like a user interface. And writing user interfaces is different than writing libraries. There's important things you do differently, and so NumPy is kind of a schizophrenic hybrid, actually. And as it's used as a library, you kind of recognize that, oh, this is weird. Why is it guessing? Why don't you just tell me an error and let me do it? As a developer, you get annoyed with NumPy. As a user, you want it to do those things, right? And so that's a concept that wasn't in my head 15 years ago, but I understand much, much better now. There's a difference between libraries and user interfaces, and you should respect that. There are three major things in NumPy. You've got the type system, dtype, the array container, and then the ufunc system. And effectively, those three systems work together to allow you to do fast math. Most people use NumPy just to get fast math, but it's really structured this way. NumPy was built on the shoulders of giants. I didn't just write NumPy out of my head, right? Nothing ever like that really happens that way. NumPy combined the efforts of Jim Huguenin, who wrote Numeric, with the efforts of the Space Science Telescope folks who wrote NumArray, and some of their ideas. We worked together to put them into NumPy. And the big thing I did spend a lot of time thinking about, and I wished I'd been a better type theorist, a category theorist when I did it, is the type system. I kind of took the old the nascent type system that NumPy had, the Numeric had, and exposed it as a Python type system. This is before C types. This is before kind of a typing module, a lot of those things like that. I see what I could have done now much better, and I've been trying to, over the past 6 years, trying to figure out how to fix it. But it's really hard, actually. Having a successful library, what is it? Don't wish, careful what you wish for, because you can't really take it back. It's really hard to go from, okay, here's this thing, now how do we fix it when I've got millions of users? That's a difficult problem. So I've been kind of thinking about that for a while in different ways. But dtypes, part of what I thought I'd do is I just, most people maybe don't know, there's this type info object at the NumPy core multi-array. If you import NumPy core multi-array, there's this type info object, and it has all the fundamental types and information about them. These character codes, the number of bytes, as well as the actual class that represented in Python. So bool, byte, ushort, uint. A lot of them. We were pretty, what did somebody say from, Stefan Hoyer was telling me, NumPy is like ridiculously over specified, ridiculously over engineered, and that's probably true. You look at a lot of things here, there's half floats actually, those were added later, and there's this date time thing here, which has been very productive. It took a while. It showed me a lot of what the challenges were with making changes to NumPy, but we added that a while ago. Then if you look, they're all instances of this generic. So each of the type objects, I just wanted to list them all out. They're actually there several times. You got things like uint32, int32, bytes, flexible, sign integer. All of these things describe a memory region. Like NumPy is a very straightforward concept, basically. It's a multidimensional array that maps a 1D buffer. It maps kind of indices to a 1D buffer. And what's in each element of that 1D buffer is arbitrary. It's whatever you want. It's a structure, it's a type, it's anything. Most people aren't quite aware of that. I mean, especially with Pandas now, it's much easier to process CSV files using Pandas. Back before Pandas, we could do, and in fact, it kind of got Wes McKinney thinking about beyond Pandas. He kind of structured arrays, which were these arrays of structures, got you kind of thinking, I can process CSVs, I can process Excel spreadsheets. You can, a little bit awkwardly, right? And so it was just tantalizing enough to see what was possible, and then fortunately, Pandas exists now to make this a lot simpler. But effectively, you define a data type that has lots of elements. So uint8, uint16, float32. Let me see if I can get out of the way of some people here so you can see the screen potentially. Oh, yeah. Thanks for that. And I'm going to move around so your camera's going to struggle here. Sorry about that. So I'm just making a D type, a bunch of lists. It's u18.8, uint8s, and then one float32 and one uint16. And I'm loading this data from UCI absenteeism at work data. It's a big CSV file with, except not commas, with semicolons, so an SSV, I guess. And load text, what we used to use to just load text files with a data type. And you look at the data type, it basically has a field and a type. Field, type, field, type. And that whole thing is basically describing a big block of memory. One of the things I really advocate for, and your GPUs love you for it, and your Intel hardware loves you if you do this, is to take your data and organize it in chunks. They call it columnar storage. It's not just columns, it's just chunks, arrays, and big chunks of data. One of the kind of problems that Java inflicted on the world is causing people to think about objects everywhere, and then laying their data out as lists of objects that scatter all over memory. Then you want to do anything with it, and your computer and your CPU has spent all its time fetching data and not doing any computation. Right, NumPy helps you think better about your data and organize it together. Array-oriented computing is a big thing I've been promoting for a long time, but record arrays do that. You can think of a record as an object, but it's all stored together, and so you can process it really, really quickly as well. Now, Pandas builds on top of that and does more, but this is just reading that data into a bunch of little elements and fields. And you can pull data out of it. How many Pandas users we have? Probably more than NumPy, right? That's what I usually see. That's just great. That's awesome. I'm serious. I'm serious. I like Pandas. I just, especially some of the things like read CSV, it's really nice, and some of the aggregations and the groupings that you can do. But if I take my original record array, and you can get a record array from Pandas too by saying 2 records. It gives you kind of a little bit of a funny one, but it is a record array. You can print an element of the record array, and what prints out? Well, it should print out, actually at this point, a named tuple. Right? Named tuples are this cool new element with structures in it. Those didn't exist back then. And so now what you get is actually this thing called a NumPy void object. When you select an element out of a structure, array of structures, a structured array, you get this void object. So if how many volunteers in the room love someone to actually add to NumPy the ability to take named tuples, like just instead of returning these these NumPy voids, return a named tuple when you grab an element like this. Any takers? Anyone, any newbie, any NumPy? Great, awesome. Let's talk about how we could potentially do that. It'll take 6 months. To write it, it will take you about a week. And then it'll take 6 months to have a conversation on the mailing list and then finally get the code accepted. So as long as you're warned, as long as you're ready for that, I'll help you. That's the joy, that's the blessing, actually, too, of open source. All right, so I don't have any time, I think. How much? We got 4 minutes. 4 minutes, perfect. All right, I wanted to show another thing, which is this vectorize. If you saw my tweets or if you follow me on Twitter, I tweeted just a little while ago because I'm doing some consulting work. I've been looking at data, and I needed to do an interpolation. And I couldn't find the right broadcasting rules in SciPy to do the interpolation I was looking for. I wanted to interpolate this huge array, and I wanted to have a different set of weights for every row. Right? So I wanted to have a different interpolating function every row. And of course, people do that all the time. They usually do it really slowly with Python, and they kind of have, they create a new object every row, and they iterate through there. And I had 70,000 rows, so I knew I wanted to do that faster. So I basically, one of the reasons that 6 years ago we wrote a compiler called Numba is Numba lets you write just regular Python code and then translate regular Python code to a map function that goes over all arrays. So vectorize is the start of that magic, and GU vectorize gives you even more magic to let you do even more complicated kind of maps. So I thought I'd give an example of vectorize because I don't think it's used enough, and it's really, really cool. Vectorize, it'll take a Python function. So I'm here doing the Levi-Civita function. Anybody know physics and Levi-Civita tensor? Oh, thank you for admitting it. Awesome. I'll raise my hand. Levi-Civita tensor is awesome. It helps you do the cross product and other kinds of products easily. It's kind of a big if statement, basically, to define it. But I want to basically make a Levi-Civita tensor. I want to compute that at every element. There's a cool little function called from function in NumPy. What from function does is you give it a function that takes indices, and then it returns the array, kind of generates that array from those indices. So, but an example of from function, it has a few of them, but this is a perfect example of how you would use from function if you had something like vectorize. So that if I give it arrays of integers, it'll give me back the corresponding array. So, but notice this Levi-Civita function, it's written just as if I, j, and k are scalars. I'm doing if I equals j, or j equals k, or I equals k. Anybody who knows NumPy knows that won't work if those are arrays. That won't work because or and actually can't be overloaded to do array processing. They just do Boolean. But these are just scalars here. What vectorize is doing is producing a single scalar function that takes integers and returns an integer. And then vectorize is going to then construct a universal function that will then send arrays in, call that function at every element, and give you the end result. That's all fine, and NumPy has a vectorize too, except NumPy's vectorize will just call the Python function. Therefore, all your elements are Python objects. This vectorize takes this Python syntax and compiles it through the magic of LLVM to assembly code, to machine code. And so this machine code is then run at every element of those arrays, and it's done very, very fast if you've written C code. You can also take this, run on your GPU as well. It's the fastest way to program a GPU I know about. So very, very handy if you're trying to do something fast. So vectorize, at vectorize, and Levi-Civita 3-3, and it produces this array really, really quickly. Okay, so I was going to tell you a little about bin count. I was going to tell you a little about XND, but I don't have any time. I will just briefly at least show you the logo of XND. Right? And if you want to know more, XND is part of my strategy for trying to improve the foundations of NumPy without directly rewriting NumPy. Right? It's sort of how can we do research and development and improve the foundations while also keeping NumPy stable and moving forward? And it's part of the approach we're taking here. So XND it's basically the concepts of NumPy, the container, the type system, the ufunc system, broken up into separable components that can be remashed in different ways and depended on by other languages, other libraries, and so forth. It's the ideas of NumPy kind of spread and generalized. So open source project as well, XND.io. Very young project, but if you're brave and eager to kind of jump in when it's very, very new, feel free. We'd love to have you. Great, that's it. Thanks, everybody.